At exactly 3:17 a.m. on November 9th, 2025, every major telescope on Earth froze. From the deserts of Chile to the peaks of the Canary Islands, one object in deep space defied everything scientists knew about physics. The data didn't glitch. The universe did. Across observatories worldwide, instruments detected the same flawless distortion, a perfect ripple through the cosmos. For several seconds, it emitted a light that shouldn't exist, a wavelength that fit nowhere within known atomic transitions. Systems recalibrated automatically, yet the anomaly held steady, deliberate, impossible, until it vanished without warning. At first, experts blamed solar interference or a synchronization failure, but the truth was far stranger. Every observatory's timestamp matched exactly, down to the microsecond, despite each running on independent clocks. Something hundreds of millions of kilometers away had coordinated with inhuman precision. In the silence that followed, panic turned to awe. Data vaults were sealed, verification systems were activated, and every secure channel lit up with the same urgent message: Priority 1. The lockout wasn't a system failure or glitch, it was replication. 3i Atlas was mirroring itself across every network that had tried to observe it. In essence, the act of watching had embedded its digital signature into the very framework of Earth's data systems. By nightfall, entire observatories had gone dark under the label data quarantine, a sanitized term masking what researchers feared most. The data had achieved a form of life, not biological, but informational. And as global observation feeds went silent, another kind of hush settled, deliberate and coordinated. Agencies stopped posting updates. Press outlets suddenly lost access. By the end of November 9th, the question was no longer if something extraordinary had happened, but how much of it would be allowed to reach the public. What began as confusion was now a controlled information blackout. Within hours, statements from the European Space Agency, NASA, and JAXA appeared, each with near identical wording. Data from current solar object studies remain under review pending calibration. The timing was too precise for coincidence. The real message beneath the corporate phrasing was clear: say nothing, confirm nothing, wait for further direction. Soon after, public telemetry feeds began failing, one by one. NASA's solar orbiter feed vanished first, replaced with routine maintenance placeholders. Then, the Solar Dynamics Observatory's ultraviolet stream looped archived footage from previous weeks. Within just one day, no open system anywhere on the planet was transmitting live footage of 3i Atlas. Global observation had gone completely dark. Inside research facilities, the silence grew heavier. Teams that had collaborated for years suddenly stopped exchanging data. Server rooms were sealed off, workstations were locked under physical watch. Those who questioned the new restrictions were quietly removed or reassigned to unrelated projects. New classified directives soon followed, labeled confidential, internal use only. Researchers were ordered to catalog corrupted data under restricted tags, no cloud backups, no offsite transfers, no discussions beyond secured terminals. At Cambridge, Dr. Sarah Chen's research team, the first to identify the harmonic frequency embedded in the lockout pattern, was abruptly told to halt all analysis. When Chen demanded clarification, she received an encrypted message signed only by an administrative code: containment priority, cease propagation. It was the first written confirmation that authorities feared the data itself could spread. Parallel incidents surfaced from the Harvard-Smithsonian Observatory. Technicians noticed subtle anomalies. Computers not directly exposed to corrupted data began losing seconds off their internal clocks, only for the time to reappear minutes later. The shifts repeated every 9 minutes, precisely. When one affected terminal was powered down, the drift stopped. The implication chilled everyone who thought the data. The synchronization disturbance had jumped from instruments to infrastructure, manifesting as temporal distortions. Rather than release their findings, administrators locked the report under classified review. From that moment onward, no mention of time drift appeared anywhere in public documentation. Instead, new terminology emerged: environmental oscillations, resonance coupling, localized feedback. evasive words to avoid the unspoken ones scientists whispered privately. Infection. Journalists who had followed 3I Atlas since its discovery quickly noticed the coordinated silence. Media inquiries were redirected to press offices, public science forums were either locked down or flooded with boilerplate responses about data recalibration. A handful of independent researchers posted cautious analyses on private blogs, comparing the communication freeze to earlier classified aerospace events, incidents where unexplained signals had been quietly buried. Those posts vanished within hours. Behind the scenes, a loose network of observatories across Chile, Spain, and Australia formed what they called the Continuity Network, a small alliance determined to keep watch using unconnected analog systems. Their telescopes operated entirely off-grid. All data was recorded on physical film, no digital storage. They confirmed that 3I Atlas was still present, though dimming slightly each night. Its rhythmic pulse persisted, steady, unbroken. That consistency suggested the phenomenon was still active, even as the world pretended it was gone. Meanwhile, technicians monitoring deep space communications began noticing interference at frequencies reserved for interplanetary probe transmissions. The distortions weren't strong enough to disrupt communications, but repeated in harmonic cycles, again every 9 minutes. When all outbound transmissions toward 3I Atlas were paused, the noise disappeared. Some believed it wasn't interference at all, but a feedback loop, the object responding through communication infrastructure itself. One internal memo, later leaked anonymously, captured the growing dread. We're not just watching it, it's watching back. The silence isn't about secrecy, it's about containment. That phrase spread quietly through research channels. Contain the feedback, contain the loop. Don't let it synchronize. Whatever the actual risk, those in command believed that 3I Atlas's influence could propagate through observation, through data, maybe even through human attention. And so one by one, observatories obeyed. Live observations ceased, ongoing datasets were encrypted and sealed, even casual discussion disappeared, replaced by a handful of encrypted offline exchanges between trusted scientists, handwritten notes scanned and sent in secrecy. But not everyone complied. Independent observatories, privately funded, often run by volunteers, refused to shut down. Lacking access to the restricted datasets, they built their own analog archives. And what they discovered disturbed even the most skeptical among them. Their film-based observations revealed subtle fluctuations in 3I Atlas's light pattern, minute distortions suggesting geometric change. The object, once perfectly spherical, now appeared slightly elongated, its brightness concentrated along a new axis. Frame-by-frame comparison showed the variation wasn't random. It resembled structural reconfiguration, as though its internal layers were shifting. That discovery didn't remain secret long. Within a day, the data spread through encrypted backchannels, reaching the few scientists still willing to share under anonymity. And for everyone who saw the images, the realization struck immediately.
If 3I Atlas truly exhibited behavior like that, it would imply the presence of a meticulously organized electromagnetic framework, something engineered rather than naturally occurring. To verify this, radio observatories around the world tuned into a broad range of frequencies during the next observation window. No classic radio transmission emerged, yet in the faint background hum, a subtle recurring pattern appeared near 60 megahertz, precisely one harmonic below the object's optical pulse frequency. The signal wasn't strong enough to qualify as intentional communication, but it demonstrated something extraordinary. Whatever mechanism caused the thermal anomaly was also influencing the surrounding electromagnetic field. In essence, 3I Atlas wasn't merely breaking the rules of thermal balance, it was actively controlling its local environment. By midday, the scientific community had officially named the occurrence Thermal Divergence Event 3A, shortened to TDE 3A. Within hours, discussion networks filled with speculative proposals linking it to phenomena such as phase conjugate reflection, negative temperature states, and even macroscopic quantum coherence. Each of these theories, however, ran into the same problem: scale. No natural object of that size could sustain quantum-level effects long enough to produce a global thermal inversion. The question shifted from how is it doing this to what allows it to do this. Surprisingly, The most promising hypothesis came from the University of Oslo's magnetoplasma laboratory. Their research team proposed that the ionized dust surrounding 3I Atlas might be acting as a resonance shell, amplifying some frequencies while suppressing others, effectively creating an artificial separation between radiation types. If true, it meant the object wasn't truly cooling or heating internally, it was manipulating perception, using its environment like an active filter to control how it appeared across different parts of the spectrum. But even that model couldn't explain one critical aspect: the timing. The temperature and brightness gap didn't vary randomly. It followed an exact 9-minute rhythm, perfectly synchronized with the recurring light pulses. That synchronization implied feedback, a self-monitoring loop, perhaps even a regulatory mechanism. As night approached, attention turned to ground-based telescopes. Amateur astronomers began contributing again, providing independent confirmations of professional data. Their smaller instruments, despite lacking space-grade precision, all recorded the same phenomenon. Visible brightness remained constant, while infrared light steadily weakened. Even with modest backyard setups, the paradox was undeniable. By evening, the anomaly escalated into its second phase. The pulses abruptly stopped. The light stabilized, but the thermal divide persisted. Infrared emissions stayed muted, while ultraviolet intensity continued to climb. 3I Atlas now radiated as though split in two, a cold surface projecting fierce, high-energy light. For the first time since its discovery, scientists could no longer agree on what they were observing. Was this a physical object, or a self-regulating system capable of adaptive behavior? Then came the data that silenced all remaining doubts. As twilight fell across the Western Hemisphere, telescopes from Chile to Hawaii turned toward the coordinates of 3I Atlas. The skies were clear, lunar interference minimal, and visibility ideal. Within minutes, reports poured in through amateur and professional channels alike. The object was visible from Earth, and its behavior matched space-based observations with eerie precision. The first confirmed sighting came from the Cerro Tololo Inter-American Observatory in northern Chile. Its 4.1-meter mirror captured a faint but distinctly defined object moving against the solar background. Not a diffuse tailing comet, but a sharp, steady light source. Every 9 minutes, the telescope recorded a tiny pulse in brightness, the same rhythm seen in orbital data. Moments later, Keck Observatory in Hawaii, La Palma in the Canary Islands, and Mount Stromlo in Australia confirmed identical readings. Every observatory across the planet detected the same phase of brightening within milliseconds of each other. That level of synchronization, observed independently through entirely different instruments, eliminated every remaining doubt. This was real, not noise, not calibration drift, not error. Observers described the sight as haunting. Through adaptive optics, 3I Atlas didn't shimmer or blur like a comet. Its glow had sharp boundaries, a confined halo, as though its light was being actively shaped. Some astronomers compared it to a breathing sphere, expanding imperceptibly with each pulse and contracting again, the entire object steadily oscillating by fractions of a percent. Though minuscule, the movement was measurable and perfectly synchronized with the temperature and luminosity cycles. Soon after came another revelation: faint reflections detected in Earth's upper atmosphere. Radio observatories such as the Arecibo Successor Array and the Canadian Hydrogen Observatory recorded transient electromagnetic fluctuations matching the pulse rhythm. These weren't ordinary ionospheric echoes caused by solar radiation. They were narrow-band reflections, aligned precisely with the modulation frequencies detected weeks earlier. Incredibly, the energy from 3I Atlas appeared to be interacting directly with Earth's magnetic field, a faint but measurable mirror-like feedback effect. At first, many dismissed it as coincidence, atmospheric interference perhaps. But once global observatories compared notes, a clear pattern emerged. The reflections occurred only during peak luminosity and always with a 1.3-second delay, the exact time light would take to travel from 3I Atlas to Earth and back through the ionosphere. The delay remained perfectly consistent across all sites. This meant the pulse maintained coherence across millions of kilometers, striking the atmosphere and returning as a detectable echo. The astrophysics community was stunned. For the first time in history, a celestial object beyond Mars had produced a measurable effect on Earth's electromagnetic environment. Researchers began referring to it informally as the mirror effect. It was as though 3i Atlas had momentarily illuminated Earth in a wavelength designed for response. Meanwhile, the Gran Telescopio Canarisca recorded an even more puzzling feature. During one of the main pulses, a secondary spike appeared, a smaller, sharper flash nested within the larger rhythm. This subpulse lasted less than 1/10 of a second, yet it repeated with perfect consistency across multiple observatories. The ratio between the main pulse and subpulse frequencies was 9:3:1, exactly matching the harmonic pattern identified earlier in the object's spectral data. This discovery tied together every prior anomaly: the synchronization, modulation, and thermal divergence. The entire system operated with mathematical precision across optical, thermal, and electromagnetic dimensions. It was far too structured to be random, yet too subtle to be deliberate communication. If it was intentional, it wasn't trying to talk, it was calibrating, tuning itself in response to environmental feedback.
As hours unfolded, ground-based observations began filling the gaps left by space telescopes. Through spectroscopic imaging, scientists detected delicate strands of ionized gas encircling the object, shimmering faintly in ultraviolet light. Yet, instead of trailing outward like a comet's tail, these threads moved inward, spiraling toward the object's center. This defied all expectations of solar wind dynamics. Rather than being pushed away by solar radiation, the material appeared magnetically pulled back in. Physicists began to suspect that 3i Atlas might be generating its own magnetic containment field, one powerful enough to draw in charged particles instead of repelling them. As data continued to pour in, one unsettling realization emerged. 3i Atlas was behaving like an active system, not a passive rock. Its responses were adaptive, regulated, and deliberate, the traits of something that operated with internal processes rather than random physical reactions. Among researchers, the term autonomous process began circulating quietly, though few dared include it in formal reports. Then, just past midnight, a final measurement deepened the enigma. As 3i Atlas moved behind a dense region of solar wind, its visible glow dimmed, but its pulse didn't. The rhythmic signal continued unaffected by light scattering or electromagnetic interference. That suggested the emission wasn't purely optical. It contained frequencies or energy bands that could pass through matter and plasma unimpeded, possibly wavelengths science hadn't yet cataloged. In an extraordinary synchronized event, every observatory, from professional arrays to backyard telescopes, recorded the same astonishing phenomenon. The light, the rhythm, the oscillations, all aligned into one coherent global signal. 3i Atlas wasn't just a solitary object anymore. It had become an event, a coordinated system that could be measured across every observational layer of Earth's monitoring infrastructure. Then came dawn in Europe, and with it another revelation. Magnetometer stations across the globe began picking up faint, rhythmic oscillations. Earth's own magnetic field was now pulsing in sync with 3i Atlas. At 2:14 UTC, the first signs appeared across observatories in Scandinavia. Small fluctuations, mere microteslas in amplitude, barely above background noise, yet unmistakably, they pulsed at the exact same rhythm as 3i Atlas's light signature. Within the next hour, the same signal was reported from Canada, Japan, and South Africa, all isolated networks using independent calibrations, yet producing identical timing results. This was not atmospheric interference. It was a planet-wide magnetic resonance, subtle but measurable, repeating every 9 minutes, and decaying with uncanny precision. That finding forced scientists to confront an unthinkable possibility. Could 3i Atlas be directly interacting with Earth? The idea was almost absurd. The object was millions of kilometers away, smaller than a minor asteroid, and enveloped in solar plasma that should have smothered any coherent signal. Yet, somehow, its emission appeared to not only reach Earth's ionosphere, but leave a detectable signature on the planet's magnetic shell. Initially, the phenomenon was dismissed as an echo effect, a reflected signal bouncing off Earth's upper atmosphere. But when analysts modeled the timing delay, the math didn't add up. A reflected signal should have returned at light speed, roughly 10 minutes after the pulse. Instead, the geomagnetic ripple arrived 2 minutes earlier than physically possible.
That anomaly became known as the reflection problem. But reflection was a misnomer. The pattern wasn't bouncing back at all, it was inducing. The pulse seemed to directly couple with Earth's magnetic field, bypassing the physical distance altogether. This pointed to something far stranger, resonance rather than reflection. The same way two vibrating strings can sync through shared frequencies, 3I Atlas and Earth's geomagnetic field appeared to be resonating together across astronomical distances. Such effects exist in the quantum realm, electron spin coupling, entanglement, but never before on a cosmic scale. The notion of an interstellar object syncing with Earth's geomagnetic rhythm bordered on heresy. At NASA's Goddard Space Flight Center, the Geomagnetism Division began tracing the anomaly using satellite-based magnetometers aboard the Thetis array. Their assumption was straightforward. The signal should weaken as altitude increased. Instead, it intensified, peaking at nearly 60,000 kilometers above Earth, right where solar wind and the planet's magnetic field reach unstable balance. The implication was staggering. 3I Atlas's pulse wasn't bouncing off Earth's upper layers, it was interacting with a standing resonance already encircling a planet. Further modeling exposed another pattern. The magnetic oscillations weren't uniform. They formed a wave front strongest over the Pacific Ocean and weakest near the poles, matching the natural flow of the solar wind. Somehow, the pulse from 3I Atlas was influencing that charged stream, modulating it just enough to shape how it contacted Earth's field. Though the total energy was minuscule, its precision hinted at coordination, even intentional feedback. At the Max Planck Institute, physicist Elena Koenig proposed what she called the plasma coherence transfer model. Her simulations suggested that a coherent electromagnetic field, such as the pulse from 3I Atlas, could phase lock with the sun's magnetic flux lines. If the frequencies matched, the pulse could effectively ride those lines, transmitting its structure through the solar wind the same way vibrations travel along a wire. This could explain both the timing anomaly and the global synchronization. It also implied that 3I Atlas wasn't deliberately targeting Earth, it was merely using the sun's magnetic architecture as a transmission medium, and Earth happened to lie along its path. But even this model failed to explain one final disquieting discovery. The echoes detected in Earth's ionosphere weren't just in sync with 3I Atlas's pulse, they contained identical fine-scale modulations. When the data was amplified and slowed down, those returning signals revealed a repeating internal structure, like a digital checksum, confirming data integrity. In other words, the so-called echo wasn't noise. It was a confirmation signal. This revelation spread quietly through encrypted research networks. The implication was radical. 3I Atlas's light wasn't random radiation. It was structured, self-verifying, and bidirectional. It was communicating with its own reflection, forming a closed-loop feedback loop with the Earth's magnetic shell. Replication attempts followed across the world. In Greenland, an ELF antenna array detected identical sub-1 Hz phase shifts, perfectly matching the envelope frequency of 3I Atlas's pulse. The pattern was no longer coincidence, it was synchronization, intelligent, deliberate, and planetary in scale.
Some scientists suggested that 3I Atlas might have entered a kind of magnetic resonance with the sun's own field, a state in which both interacted to produce periodic bursts of energy. But those kinds of discharges usually weaken over time, not become sharper or more defined. Another theory proposed a gravitational lensing effect, where some hidden celestial body amplified its light at regular intervals. Yet orbital data quickly ruled that out. No such alignment could possibly exist. That left one deeply unsettling possibility. The object itself was creating the pattern. It wasn't reacting to something external. It was adjusting, internally, as if recalibrating itself. The pulse was deliberate. When researchers charted the pulse sequence across time, they found subtle shifts in amplitude forming a secondary wave, a modulation that wrapped around the smaller pulses like a carrier signal in a radio transmission. This pattern resembled amplitude modulation, where information isn't stored in frequency, but in the intensity of each oscillation. To investigate, analysts ran the signal through demodulation algorithms used in telecommunications. The result was both unclear and deeply intriguing. Sequences of repeating numeric ratios, 17 of them,
appearing in every third cycle. No natural process known to science produces such mathematically precise periodicity. At CERN, a team compared these ratios to known atomic and molecular patterns. They didn't match any standard spectral lines, but they bore a faint resemblance to harmonic arrangements seen in quantum oscillator simulations, models designed to regulate energy distribution. If that interpretation was right, then 3I Atlas wasn't venting energy chaotically, it was managing it, intentionally. Within hours, the scientific community fractured into two opposing camps. One argued that the pulse came from mechanical dynamics, perhaps a redistribution of mass or a rotation stabilization, like a spacecraft firing microthrusters to study itself. The other insisted it was electromagnetic feedback, an interaction between charged dust and magnetic fields producing sustained oscillations. Both theories failed the most basic test. Neither could explain the pulse's extreme precision or its synchronized timing across the entire globe. Then came the discovery from the solar orbiter. Using high-speed imaging, the probe captured faint luminosity gradients, concentric halos expanding outward from 3I Atlas during each pulse. These weren't particles being ejected. Their expansion velocity was far too high. They were energy shells, waves of light radiating out like ripples in water, fading as they traveled into the solar wind. Their spacing matched the pulse frequency exactly. When modeled, the event resembled a controlled burst of energy, followed by an immediate magnetic collapse. To put it in human terms, it was less like an explosion and more like a system diagnostic. The metaphor spreading among researchers became, it's checking its own pulse. By that evening, NASA's internal message boards filled with cautious technical language, phase-modulated emission, self-harmonic coherence, active stabilization. The public press release, however, remained diplomatic, recurrent optical modulation of unknown origin. But what came next rattled even the most reserved scientists. As the pulses continued, inconsistencies began appearing between temperature readings and brightness data. In physics, these should correlate perfectly. Hotter means brighter. Yet for 3I Atlas, that relationship had broken down completely. The first sign appeared in data from the James Webb Space Telescope. Its near-infrared spectrometer, continuously monitoring the object since the pulse began, showed a steady drop in temperature, several Kelvin, during the brightest emission phases. That alone defied astrophysical logic. Luminous objects shine brighter when they heat up, not when they cool down. But simultaneous readings from the solar orbiter and SEO probe revealed the opposite trend, a dramatic increase in thermal output in the ultraviolet and extreme UV ranges during the very same intervals. In other words, depending on which wavelength you measured, 3I Atlas appeared to be heating up and cooling down at the same time. At first, analysts blamed calibration errors. They checked the filters, aligned baselines, and cross-tested against reference stars. Every instrument passed perfectly. That left only one explanation. The data was correct. The object was truly exhibiting dual thermal behavior, rising in the ultraviolet, dropping in the infrared, both centered around a narrow band of visible light that remained unnervingly stable. No natural phenomenon produces such spectral bifurcation. Even in quantum materials on Earth, thermal transitions occur uniformly. Yet here, two energy systems seem to be competing within the same body. At Harvard's Astrophysics Center, hushed discussions turned toward a radical idea: energy phase segregation. The concept suggested that 3I Atlas was dividing its own energy internally, channeling high-frequency radiation outward while suppressing lower-frequency heat. The closest earthly comparison would be a laser cavity or a photonic crystal, where specific wavelengths are amplified while others are deliberately dampened. But in nature, such selective control requires structure, precision design. That was the unspeakable implication. Something inside 3I Atlas was managing energy flow deliberately. When scientists overlaid thermal maps from multi-spectrum data, the pattern grew even stranger. The coolest zones perfectly overlapped the brightest areas. The object's most luminous regions were paradoxically its coldest, a direct violation of the Stefan-Boltzmann law unless heat was being actively redirected. The pattern deepened as the pulses went on. After each plash, the hot and cold regions appeared to move, trading positions as though participating in some kind of internal circulation. Scientists called it thermal breathing. Each cycle followed the same rhythm as the light pulses, offset by a few seconds, a consistent delay, suggesting a controlled process. When analysts charted that lag, they realized it matched the exact amount of time energy would need to traverse a structure about 200 meters wide, the known size of 3I Atlas. That meant the heat shift timing wasn't random. It was perfectly scaled to the object's physical dimensions. Physicists began considering a concept once confined to science fiction: internal field alignment. In advanced materials, heat can be directed by manipulating electromagnetic lattices, forcing energy to flow along chosen paths.
In essence, the emission behaved as though it understood exactly where every observer was positioned. At Caltech's data synchronization lab, researchers first suspected a systemic malfunction, perhaps a glitch in the global atomic time network that could have forced identical timestamps across all observatories. But when they cross-referenced data from gravitational wave detectors, systems running on completely independent timing protocols, they discovered the same eerie synchronization. Even instruments that hadn't been observing 3I Atlas directly registered a sudden, inexplicable resonance in their calibration lasers at that very instant. That discovery raised a deeply unsettling question. Could an astronomical object adjust its emission to account for the light travel delay between itself and every observer? To accomplish that, it would need precise awareness of each detector's distance, its velocity relative to Earth's rotation, and even atmospheric effects, a level of computation far beyond coincidence. The deeper scientists dug into the data, the stranger it became. High-orbit satellites, including those part of SO and STEOA missions, had captured the event roughly 8 minutes before Earth-based observatories, exactly matching the time it takes for light to travel from the sun's region to our planet. Yet when their readings were converted to universal time, the timestamps aligned perfectly with the ground data. Both streams, spaceborne and terrestrial, appeared to operate as if coordinated by a single master clock. Researchers began referring to the phenomenon as the synchronization anomaly, internally abbreviated as SA1, marking it as the first recorded instance of its kind. What made SA1 even more unnerving wasn't its precision, but its selectivity. Only instruments focused on 3I Atlas displayed perfect timing alignment. Observatories tracking nearby regions of the sky, monitoring solar activity or other celestial bodies, showed no such effect. Their clocks behaved normally. The implications were staggering. It suggested that 3I Atlas wasn't merely reflecting or emitting radiation, it was somehow modulating its light in direct relationship to being observed. In theoretical physics, that concept echoes quantum observer dependence, where the act of measurement influences the outcome. But such effects are confined to the subatomic world. Seeing this kind of coherence across astronomical distances defied everything known about physics. To rule out human or instrumental error, several teams reran the experiment under controlled conditions the following night. They pointed their instruments slightly away from 3I Atlas to measure near-body stellar emissions as a baseline. The results came back normal, but the moment they redirected their focus back to 3I Atlas, the synchronization effect returned instantly. The correlation was absolute. Observe 3I Atlas and the clocks locked. Look elsewhere and they drifted as usual. This phenomenon quickly drew the attention of timing and systems experts at CERN, scientists familiar with tracking subatomic collisions and identifying artificial correlations. When they applied their collider synchronization algorithms to the dataset, the output revealed something extraordinary: phase alignment. That's when multiple oscillating systems resonate in harmony without a physical link. Such alignment can appear naturally at quantum scales, but across planetary distances, it requires an external coordinated field.
If such a field exists, it's invisible. No radio waves, gravitational fluctuations, or neutrino emissions corresponded to the event. The only detectable signature remained optical, matching precisely the wavelength of the mysterious emission itself. That meant the light might not have been simple illumination, it could have carried timing data within its structure. If that was true, 3I Atlas wasn't just radiating light, it was transmitting information. The emission was no ordinary flash, it was a precisely structured pulse, a globally synchronized signal that unified detectors around the world for a few fleeting seconds before vanishing into background noise. At the European Space Agency, engineers began informally calling it the clock event. A confidential internal note circulated soon after, stating bluntly, "Whatever this is, it's not behaving like debris or cometary matter. It's demonstrating awareness of observation." Across academic networks, the tone of discussion shifted rapidly, from fascination to quiet unease. For the first time, scientists were forced to consider the unthinkable. What if 3I Atlas wasn't merely reacting randomly, but relationally, as if responding to being watched? As observatories recalibrated after the synchronization anomaly, attention turned to a subtle rhythmic flicker reappearing in 3I Atlas's brightness curve. At first, teams assumed it was post-event interference, perhaps residual atmospheric turbulence or electronic noise following system resets. But that theory unraveled within minutes. The rhythm was too precise, too deliberate, and once again globally consistent. This wasn't the first time 3I Atlas had pulsed. Weeks earlier, astronomers detected a faint periodic dimming every 27 minutes, a cycle so steady that some compared it to pulsars. Yet pulsars rotate, and their radiation is electromagnetic, not optical. 3I Atlas had no measurable spin period and emitted no radio or X-ray signals. The earlier pulse eventually faded, leaving researchers divided between theories of thermal oscillation and structural motion. Now the pulse had returned, stronger, faster, and unmistakably patterned. Across 3 continents, identical light curves appeared on monitors showing less than 1% change in brightness, but all in perfect sync. Even more astonishingly, the cycle had shortened, from 27 minutes to just under 9. The new rhythm didn't correspond harmonically to the old one, it represented an entirely new behavior. For scientists accustomed to predictable periodicities, this wasn't a recurrence, it was evolution. At the Harvard-Smithsonian Astrophysical Observatory, Dr. Marcus Lumsden described the pattern as a coherent beacon with an adaptive heartbeat. His words were not metaphorical. Fourier analyses showed each pulse carried multiple harmonic layers, 3 dominant peaks recurring in perfect mathematical ratios of 1 to 2 to 4. These harmonics remained intact through atmospheric distortion, cloud cover, and even imperfect detectors. It was intrinsic, part of the light itself. NASA's Solar Dynamics Observatory compared the pulses to solar logs. There were no matching flares, coronal ejections, or magnetic disturbances. The emission was self-generated. What truly startled analysts was its consistency. Each pulse emitted identical photon counts with variation no greater than 0.03%. That meant amplitude control, real-time adjustment at impossible precision. Even amateur astronomers with modest telescopes began detecting the same beat. Their low-sensitivity instruments should have been overwhelmed by noise, but the pulse cut through cleanly, like a laser tone across space. It was coherent, powerful, and stable, phase-aligned across vast cosmic distances. By midday, speculation had consumed every research network on Earth.
The scientific community had witnessed 3I Atlas behave unpredictably before. Its erratic movements, its inexplicable bursts of energy, its pulse-like emissions. But never anything like this. Never something that disrupted every monitoring system at once. In the tense hours that followed the anomaly, researchers posed the first question. What exactly did we see? Data analysis pointed to an incredibly narrow spectral line, positioned right between ultraviolet and visible light. This range didn't match any known element, compound, or molecular transition. No recorded emission on Earth or in space had ever displayed that exact frequency with such precision and brightness. Yet every observatory that had 3i Atlas in its field of view detected the same signature, a thin, unwavering line lasting just under 4 seconds, long enough for instruments to lock onto, yet too brief to fully capture its physical structure. Spectroscopy teams at Mount Taillet and the European Southern Observatory combed through their records. The signal wasn't reflected sunlight or scattered debris. Its characteristics were those of an emitter, not a reflector. In other words, it wasn't mirroring light, it was generating it. That revelation overturned earlier assumptions. 3i Atlas, already known for its unpredictable energy behavior, had seemingly produced a brand new emission type entirely, on its own. Even stranger was the absence of any corresponding heat activity. Normally, high-energy radiation is paired with spikes in infrared activity, but data from the James Webb Space Telescope showed the object actually cooling during the event. Not heating, cooling. At NASA's Goddard Space Flight Center, analysts checked for cosmic ray contamination. High-energy particles can sometimes trigger false positives, but the identical readings across so many independent instruments made that explanation impossible. A cosmic ray strike would scatter across data logs inconsistently. This signal, however, was synchronized perfectly. Telescopes separated by continents and oceans, under different weather conditions and sky orientations, all recorded the same emission at the exact same universal instant. The odds of such a coincidence occurring naturally were practically zero. What made the light so bizarre wasn't only its existence, it was its structure. When decomposed spectrally, scientists noticed fine oscillations within the band, tiny rhythmic modulations that repeated in perfect harmonic intervals. This wasn't random radiation. It was organized, patterned, and deliberate in frequency spacing, like a coded rhythm hiding within a beam of light. Some analysts speculated these harmonics indicated interference from multiple coherent sources, perhaps internal components within 3i Atlas operating in flawless synchronization. By mid-morning, the question had shifted from what is it to what could produce it. One theory involved exotic plasma reactions or magnetic reconnection within metallic vapor fields. Yet those events are typically chaotic, not harmonically stable. Others proposed quantum coherence effects, similar to Bose-Einstein condensates, but on a cosmic scale that our physics doesn't yet allow. Then came the energy analysis. Using intensity readings and distance estimates, scientists calculated the total energy output to be roughly 1/3 of a typical cometary outburst, powerful but contained. The issue wasn't energy, it was precision. The wavelength deviation remained stable to within 1 part in a billion. No known natural process maintains that kind of engineered level accuracy. Archived data from previous weeks revealed faint irregularities in 3i Atlas's emissions, subtle shifts that had been dismissed as noise. Now they formed a coherent progression. It was as if the object had been tuning itself, adjusting toward a precise goal. The European Space Agency cataloged the event as dataset L1, short for Light 1. They noted another oddity. The emission occurred exactly during a lull in solar wind activity, suggesting 3i Atlas may have timed the release for maximum visibility. Whether coincidence or intent, it resulted in the clearest signal ever recorded. The discovery split the research community. Some argued for a previously unknown physical state, a complex interaction between ionized metals and interplanetary magnetic fields. Others hesitated, pointing out that the modulation looked too structured to be random. Perhaps not intelligent in the human sense, but organized, purposeful. That difference mattered. A system can be structured without consciousness, but structure always implies rules, and rules imply control. In Cambridge, Dr. Sarah Chen's analysis of the light's waveform revealed a near-perfect harmonic ratio of 3:21, an alignment so uncommon it's rarely seen even in engineered systems. Her internal memo described it as
a coherent triad within noise: statistically deliberate. Those three words, statistically deliberate, ignited fierce debate. If it was deliberate, then what or who was behind it? Despite speculation, one fact remained unchallenged. Every observatory saw the same impossible light. A beam that appeared from nowhere, violated known emission laws, and disappeared before any secondary instruments could triangulate its origin. By sunrise on November 9th, disbelief had turned into disciplined investigation. From NASA's Deep Space Arrays to small amateur observatories in Europe, teams began comparing timestamps. Minor discrepancies were expected: tiny offsets from equipment lag, signal delay, or GPS calibration. But instead, the logs revealed something terrifyingly precise. Every record matched, down to the millisecond. For astronomers accustomed to imperfection, that was more unsettling than the anomaly itself. Even the most synchronized atomic clocks show slight drift due to time dilation or network routing. But here, every observatory, including those completely offline, registered the same timecode. At Japan's National Astronomical Laboratory, an independent team verified the raw data. Their conclusion was indisputable. The emission struck all detectors simultaneously at exactly 341,702.092 UTC. The difference between the fastest and slowest readings was under 1 microsecond. Such precision doesn't occur naturally. In ordinary astrophysical events, even light-speed signals arrive slightly staggered due to atmospheric or geographical variables. Here, there was no delay whatsoever. The conclusion was staggering. Either every system on Earth experienced a simultaneous calibration anomaly, a statistical impossibility, or the emission itself had been pre-adjusted to compensate for light travel delays.
The data soon revealed something extraordinary. A portion of the pulse's energy wasn't remaining within the expected electromagnetic spectrum. Instead, it was transforming into ultra-low-frequency magnetic oscillations, precisely matching the resonance band of Earth's own magnetic field. This meant the object wasn't merely radiating visible light. It was functioning as a multispectral modulator, bridging vast sections of the electromagnetic spectrum to achieve perfect resonance across multiple scales. For researchers, this was a profound and deeply unsettling revelation. If 3i Atlas could transfer energy simultaneously across so many frequencies, it operated on physical principles beyond any known human technology. Its coherence ignored the usual limits of thermodynamics, dispersion, and attenuation. And if it could influence Earth's magnetic field directly, it meant the planet itself was now a participant in the phenomenon, whether humanity liked it or not. Publicly, no agency acknowledged the event. Official reports remained quiet, sterile, and uneventful. But privately, observatories were ordered to keep recording, without commentary or speculation. Government surveillance satellites subtly shifted orbits. Internally, a new classification began circulating within data-sharing networks: Solar Interference Event. It was a bureaucratic disguise, a label meant to bury the incident inside routine solar monitoring. Behind the scenes, however, the scientific tone had changed entirely. The so-called reflection problem had exposed something researchers were reluctant to say aloud. 3i Atlas wasn't broadcasting blindly into space. It was interacting, adjusting its emissions based on the instruments observing it, sustaining synchronization through observation itself. And just as debate intensified over whether the anomaly was a natural phenomenon or a form of intelligent design, the next stage began. Not in light, not in magnetism, but inside the digital infrastructure used to record it. The first anomaly surfaced at the European Southern Observatory at 0307 UTC.
Their automated archiving system, tasked with storing live telescope telemetry, froze mid-transfer. Operators assumed a software crash. But upon reboot, they discovered something far stranger. All 12 hours of 3I Atlas data were still there, yet every single file was unreadable. From spectrographic logs to magnetic field traces, all displayed identical checksum mismatches, as though corrupted in the exact same way. Within half an hour, identical failures struck observatories in Hawaii, Chile, and Japan. Each used different hardware, encryption systems, and firmware, yet the results were indistinguishable, the same corruption pattern replicated globally. Ordinary data corruption follows randomness. It scrambles individual bits, truncates file headers, or disrupts storage midstream. But this wasn't random. Every affected file contained the same checksum anomaly, offset by exactly 8,192 bytes, too precise to be coincidence. What made it even stranger was isolation. None of the affected systems were network connected at the time. The corruption appeared spontaneously on physically separated machines with no shared communication path. At NASA's Goddard Space Flight Center, engineers compared the damaged datasets and uncovered a disturbing alignment. The corrupted segments matched precisely with the timestamps of the synchronization pulses, the same moments Earth's magnetometers detected resonance peaks. It was as if whatever propagated through space had also passed through the digital recording systems, imprinting itself directly into the data layer. Cybersecurity teams assumed a coordinated intrusion, but the logs told another story. No foreign IP traces, no admin overrides, no unauthorized access, no file transfers. The data wasn't stolen or deleted. It was modified in place, simultaneously across the world. One analyst summarized it succinctly. This isn't code. It behaves like radiation. Over the following hours, attempts to restore the corrupted files only deepened the mystery. Offline backups, stored in shielded vaults disconnected for days, showed the same corruption when powered on. Even archival optical discs recorded earlier now exhibited identical checksum mismatches, as though corrupted in the exact same way. That was impossible. It violated both the logic of hardware and the flow of time. By dawn, the phenomenon had a name: the data lockout. The title came from an internal European Space Agency memo that read simply, "Do not attempt additional restores. The data is present but inaccessible. Treat it as physically encrypted." That word, encrypted, ignited waves of speculation. What if the corruption wasn't random at all? What if it was intentional restructuring, a kind of encoded transformation rather than destruction? Some data scientists noted that the 8,192-byte offset corresponded to a power of 2, a foundational constant in computing. That couldn't be coincidence. If 3I Atlas had somehow electromagnetically interacted with the recording hardware, it might have produced bit-level modulation, a deliberate, structured alteration. At CERN, researchers began testing that theory. When they plotted the corrupted binary streams as waveforms, a faint rhythmic pulse emerged. It wasn't static. It repeated every 9 minutes, the same cycle as the light emission from 3I Atlas. The corrupted bits weren't random errors. They formed a repeating digital pattern consistent across all observatories worldwide. Every telescope's storage now held an identical digital echo of 3I Atlas's pulse. The implications were beyond staggering. No solar flare, no background interference, no known physical process could produce such a coordinated global signature. This was not chaos. It was precision. The corruption was selective, too. Only datasets containing 3I Atlas were altered. Files involving Mars, Venus, or deep sky scans remained pristine. Within hours, this critical detail leaked onto a private astronomy forum. The post was deleted within minutes, but not before screenshots circulated. One chilling line from the post read, "The object knows what we're watching." That phrase spread quickly through encrypted researcher chats. Some laboratories immediately severed digital connections between their telescopes and servers, reverting to analog capture methods, direct optical projections onto photographic plates. Ironically, these analog records produced the clearest images yet. On film, 3I Atlas appeared calm, luminous, without visible distortion. But when those plates were digitized, the corruption returned. The very moment the data became binary, it changed again. This led to a radical, unsettling hypothesis. 3I Atlas wasn't just emitting electromagnetic energy, it was manipulating information itself. Its pulsing structure seemed to induce resonance inside microelectronic systems, subtly reconfiguring data integrity without harming the physical devices. In essence, the phenomenon behaved like a self-writing message, a signal that could alter its own observation. By late afternoon, communication between research facilities became cautious, almost paranoid. Data sharing stopped entirely. Only verbal briefings or hand-delivered encrypted drives were trusted. But even those who continued studying the digital fragments noticed something even more disturbing. The corrupted files were changing on their own. Each time a copy was made or opened, small patterns evolved, gradually forming coherent sequences that hadn't been there before. No known system could account for this. At Cambridge, Dr. Sarah Chen's team made a breakthrough. When they overlaid corrupted binaries from different observatories, the mismatched fragments aligned like puzzle pieces, forming a unified symmetrical waveform. When visualized, the waveform displayed repeating harmonic inflections in 3:2:1 ratios, the same numerical structure found in 3I Atlas's light patterns, its magnetic oscillations, and its pulse timing. The realization was undeniable and terrifying. The same signature was now encoded across physical, magnetic, and digital systems. The phenomenon wasn't spreading data corruption, it was spreading coherence.